you switch your x and y's. That is because all the x's and the y's switch in the inverse. So if you have the 0.23 on your original, the 0.32 is on the inverse. Okay, so all the x and y coordinates are just switched. So the first step, whenever you want to find the inverse function of whatever function you're dealing with, is you want to switch your x and your y variables. Now, this equation does not have a y variable, but whatever your your function notation acts like a y right here. So we're going to switch those. We will have x equals 2/3 y minus 5. Okay. Once we have switched our x and our y's, we want to solve for the new y. Okay, so we want to solve for that new y, and you're going to solve this just like you'd solve a regular equation, but you won't get a number answer. You'll get another equation as your answer, because like the first thing we would need to do here is we would need to add the 5, and you can't add 5 to x because x is a variable and 5 is a number, so you just have to write it like this: x plus 5 equals 2/3 y, like that. Okay, we are trying to get that y by itself. What would we have to do next? I got a 2/3 I've got to get rid of. How do I get rid of that? What? I love multiplying by 3/2, and that's definitely what I would do. That seems weird, though. What were some of the rest of you thinking? I would, yeah. But a lot of kids tell me to divide by 2/3, which is good. I mean, like, dividing by 2/3 is what you're doing right there. But when you divide by 2/3, what do you have to do to divide fractions? Flip the second and multiply. So you can just do that from the beginning, like you said there, James, and it will be easier because you're going to flip that 2/3 right there if you divide, so you get 3/2 times x plus 5. They may or may not distribute that, and they will usually write it back with inverse notation. So f to the -1 power of x, that notation right there means the inverse of f. So it would be 3/2 x plus 5 right there. Okay, so this is just a basic inverse that you would be doing. It could have some different stuff in the equation. It might be like there might be a cube somewhere. There might, it might just be like might not have the fractions. It might be even easier than this right here. All right, so this is your inverse function. I want to skip over and look at example 3 because it's harder. Okay, the process is the exact same, but it's a more difficult problem. Okay, so what you're going to do at the beginning is still the same. You're going to that's your y. That f of x is your y. You're going to switch your x's and y's. X is going to equal 5y plus 2 over 3y. What makes this one harder is you've got 2 y's. Okay, we didn't have 2 y's in the other problem, and you cannot solve for y when there are 2 of them. Those have to be combined. But you can't just put them together right here. If you did like divide right here and sort of cancel them out, you would also have to divide over here. It'd have to be a love connection. You could not just say that's 5/3 right there. It'd not just mark out your y's. Then you don't have a y to solve for at all. That'd be terrible. So, so what we're going to do for this problem, usually I would let you struggle with it for a minute, but we don't have time for that. So what we're going to do, if something is in the denominator of a fraction, you really cannot solve for it. So to get this out of the denominator of the fraction, I'm going to multiply by 3y over here, because that's like 3y over 1, and the 3y on top and bottom will cancel. But if I multiply the right side by 3y, I must also multiply the left side by 3y. So that gives me 3xy equals 5y plus 2. It doesn't, no. They typically are going to write it in like alphabetical order, but it's equivalent either way. So right here, still got 2 y's. Now normally what I would try to do is try to combine those y's. But can I put 3xy and 5y together? I cannot, because this has an x and this does not. So I can't just combine those. If I had, this isn't the problem, but if I had 3y equals 5y plus 2, I'd just subtract that 5y, right? And I'd get negative 2y equals 2. But that is not what I've got. I can't put them together like that. So what we're going to do at this point, we're going to move everything that has a y to one side. So that'll be 3xy minus 5y, because when we move that 5y to the left side, we have to change its sign. We're subtracting it to move it over there, and that'll equal 2. And I cannot put those together, but both of these terms have y's. So I can factor out a y. So I can pull a y out right here like a greatest common factor, and then I have 3x minus 5 left on the inside of the parentheses. Okay, here. All right, and then the last thing I want to do, that's y times that stuff in the parentheses. So I could divide by 3x minus 5 right here, like that, and now the y is going to be by itself. So I would get y equals 2 over 3x minus 5. They probably would turn it back to inverse notation. So when you see these with fractions and more than one x, this is the general strategy that you want to use. Multiply by the denominator, move all the y's to one side, factor it out, and divide for that. Okay, so you're not